Okay. Question 14, part C. Points A, B, and C have coordinates 5, -1, 0, 2, 4, 10, and 6, -1, 4, respectively. Okay. I assume we're still on planes here. Ooh, 3 parallelograms. I'm gonna have to draw this, I think. Interesting. While I'm thinking about this, let me read what Jeff just wrote. Off to ring theory. Yeah, but I don't blame you. Um, the integral of the distance. Are you talking about like arc length there, Jeff? Okay, and I guess if you're minimizing it, then maybe you just end up with a distance formula once you derive it. I guess it might be a chain rule mold or something. Oh, no. Okay, Jeff. Yeah, I'm still not sure, but that's an interesting approach. Let's think a bit more about this one. Point D is such that A, B, C, and D are vertices of a parallelogram. Find the coordinates of 3 possible positions of D. They don't say the 3 either, so I assume there's even more. They just need to find 3, but there may be more. Uh... Can we plot points in 3D Desmos? I assume we can. Come on. Points are 0 to... Oh, it's true. But if it exists, a point could maybe 0-dimensional, but could exist in 3D space, right? I don't know. I feel like it's more of a philosophy thing. So 5, -1, 0. What happens if I just say 5, -1, 0? Do you give me that point? You do. Okay. Hype? Should need to plot a ball. Oh, I guess so. 2, 4, 10. Can I do it all with the same 2, 4, 10? Like, will that make 2 separate points there? No. Okay. I need to zoom out to see this other one. Oh, actually, let's still... Why are you rotating? I don't like it when you rotate. Okay, thank you. Okay, so you actually can do multiple in one. I think I like that. Uh, I don't really know how to use it. I have heard of it, though. And Jed, a mod around here, loves to use it. Similar to Desmos? Yeah. He showed me it a few times in screen share. I just haven't learned it for myself. Okay, so just looking at these 3 points. So actually, Thunder, we should start off with the more basic. Do you know what a parallelogram is? Probably would have been important to start off with that part. Two sides are there's 2 pairs of parallel sides. Like all the sides are parallel. So like this, yeah. Well, there's 2 different definitions, I guess. Some people say it's at least like 1 pair of sides. Some people say it's two pairs of sides, but actually, or maybe I'm getting it mixed up, but oh shoot, is that going to be important to this question? Because if all four sides, or rather, there has to be two pairs of parallel sides. Doesn't that mean we only have one possible thing? I was getting a little confused on that when I was trying to think of this. The book's answer. Okay. What are the book's answers? Because that's going to help it. It's going to help me figure out how to explain this. Because I think there's two different definitions of parallelogram. Rowdy, in like an hour and a half-ish, 2-ish hours, I will be. All right, Thunder. If you'll be around then, I'm happy to hop on DayZ. Are they, Bob? Because I remember I might be getting my conversations mixed up, but I thought there's one definition that says at least one pair parallel sides, another definition that says exactly two parallel sides, or something like. Or maybe that's for trapezoid. Or not on Azalea. Oh yeah. I don't know what the queue is like, but I played it on Friday and it was a good time. Oh, that's for trapezoid. Okay, in parallelogram, I guess it just has to be. So how like I think I can clearly see like there must be one point somewhere around here. Okay, I'm fresh right now on Azalea. Yeah, Jeff, please do. Like there must be one point somewhere around here to make that can make a parallelogram. I don't see like how else would you make one though? Oh yeah, so any point would have to exist on that plane. Is what you're saying, Jeff? Okay, this is the book answer. Oh, you pair them, you draw the lines differently. So I was thinking, oh, okay, if this was geometry, we'd actually be able to name the points. Can I still, like A? No. It's like, I guess you could, like, when connecting these 2 points, you could draw the line down or you could draw the line, well, never mind. Or you could draw the line like, no? You could like connect this point over here to this point, or you connect it down here to that point, I guess. No, please. For math, I do not mind a bit of backseating within. I it's not like super ridiculous, but I never want to give bad information. So if I'm saying something wrong, I definitely want someone to correct me. Hey, Talos. I can definitely see two here. There's supposed to be three, at least three, according to the books. It says find three possible positions of D here. And so I can see how getting the equation to the plane could maybe get us two of those points, or presumably it'd have to be all three. Unless I'm not thinking three-dimensionally enough. Uh, Consider 3 points in the xy plane to make it easier, then extend it back to 3D. That might be a good exercise. Okay, so yeah, Let's try that, Jeff. So I'm just gonna make an arbitrary kind of 3 points here just for the sake of a demonstration. I shouldn't draw them quite like that though, I don't think. So if we had these 3 points, that's what I'm wondering about Thunder. We could connect the dots like this, and then we would have to draw our 4th point D like right there. And that's one parallelogram. Or in red, we could connect these dots over here, and then our point D would be up here. And I don't see a third possibility in 2 dimensions here. Unless I'm crazy, which is always possible. Am I crazy? No. Maybe, probably, but... Can you do another from the left? Oh! Yeah, why not? Okay, yeah. Great call, Thunder. So you could do one like out here, right? Wait, how's this? I need... Actually, how's this going to work if I do it? I think if I did it like that, this is a parallelogram. And I guess we also have one to the right? Or would that just end up being this? Okay, so these stuff can all exist on the same plane. And so I think we could, how to get the answer, I think isn't going to be that bad, because we can add constraints to make the calculations easier. Actually, well, no. Parallelograms, they have to have equal sides. I don't know if they have to have equal sides for a parallelogram, but we definitely can make them have equal side lengths. Actually, yeah, they have to have equal sides if everything is parallel. Three combination of sides with 3 points. Oh, okay, that's a nice way of thinking about it. Yeah, I was trying to figure out like a fourth way, but I couldn't quite like do it. Okay. So I know I would do this in a very geometric way, but I feel like it's not the way that the book would have you do it. Let's look at how they phrase things here. Because they're doing this weird like origin to point thing, which I don't entirely understand, but I'm sure it works also. Yeah, so the issue we've run into before with Thunder is that the rep does does things in a very particular way that I haven't seen before. So that's been part of the struggle here, where I know the way that I would do it, but it's not the way that Thunder is supposed to do it. That's why I'm trying to figure out like how I want to tackle this. So, and I guess this kind of says explicitly like you start with these pairings and you work out the rest from there. OD is equal to OA plus BC. Really? I wonder where you get this from. So O in this case means the origin. And they do things like vector from the origin to A plus, well, I guess they're talking about, no, that it feels very weird to mix points and vectors like this, but I don't like this dude. Um, like it makes me uncomfortable to in one moment write it vertically like this, and then in another write it horizontally like this. But I think I know why. It's just I don't know, man. BC is parallel to AD. Yes. Oh, for figuring like this part out. So if we, okay, I kind of want to go back to my to the two-dimensional thing we have going here. Maybe I'm going to draw a second set of coordinate axes though. Okay, so they gave 3 minutes for that question? Like on a test? Or like what context is that? Because that's crazy. If we were to name them just like A, B, and C, this I know it's a weird way to do it, but yeah, sure, Bob. Wow. So it's 14 part C. Oh, it helps to actually bring up the browser, right? 14 part C. I'm going to move it around a little bit too so I can keep on working. Like there. Okay. So trying to figure out it's like if we named our point D to be here, I drew these points a bit bad, but we would take A and B to be parallel, or A, B, and C, D to be parallel. And I want to figure out what they're trying to say with the whole like where are we drawing the origin to? Like why are we drawing it with the origin? That's what I want to figure out. I'm sure there's a linear algebra way to do this too. I don't want to go down that road, but I'm sure it exists. Let me look back at the answer here. Because I want to do this in the way that Thunder is supposed to, not just in the way that I would want to. Do OC plus BA to get OD. OC plus BA. That sounds like it would be true. Oh yeah, because these sides have to be the same length. So yeah, okay. Oh, that's I see. So yeah, BA and CD are the same thing. Just like, you know, they start from different spots, but they're still basically the same thing. And so I think you're right that OC plus AB would be OD. Okay. I think that I think you're right with that rationale, Thunder. And I guess OD is just your answer. You get the question? All right, I'll leave it there for you. uh, or I won't try to like explain it further. But if you run into anything else, let me know. It's an interesting way of doing it. It's not very intuitive to me, but just probably because it wasn't the way that I was taught to do it. So I think the way that you're being taught is building into like a lot of linear algebra concepts, just in a different way than it was introduced to me. The algebraic way is probably going to be harder, or like the way that I was thinking. It's like you'd have to get the length or the distance from A to B. And I was thinking, oh, then we can like basically make a line between those 2 points and just shift the line like up or down, and then use a thing in that line. It's easier for me to follow. It'd be a lot of calculations though. So this is actually a lot less calculations if you can get your setup right. Linear algebra is sorry, because it's like it's the study of like, I mean, well, let me just look it up, because if it's all about like matrices and vectors, and the thing that you're doing with a plane looks a lot like something called eigenvalues and eigenvectors, which actually, let me look that up. Well, I mean, it's gonna be a little hard to just like drop eigenvectors and eigenvalues on you, but it's basically there's a lot of things called like linear transformations, which are, you can have your normal XY coordinate axes that are like perpendicular. You can go from those to coordinate axes that are like basically at an angle, and they're slanted. And as long as your things are set up right, you can actually still get everywhere you want in that plane. It's the exact same, even though it looks different. I don't know if this Wikipedia page is going to be all that helpful. And the thing that you're doing with planes is kind of a reflection of that. Of the idea of going from your normal, we call them orthogonal axes, I think, when they're perpendicular, to slanted ones. I think it's the simplest way that I can put it with my very limited linear algebra knowledge. Probability distributions, Jeff, I learned them a bit. I'm pretty rusty on them. If you have a question, I might be able to Google things and figure it out again. Weird ratio problem? Oh yeah, Thunder, bring it on. You don't have to make it your last question if you end up having more. Oh gosh. This one looks like it's just trying to confuse you. Let's see if we can work through it. Okay, island X is a small island. In the winter of 1986, the ratio of natives to tourists on the island was 7-1. Okay. From 1987, native tourists on the island was 155 to 69. Okay. Oh god, I've done problems like these but before. We need to figure out a good way to attack it. I think we're gonna have to potentially work backwards here, or you don't know the answer? Okay. You're right, this is a weird ratio problem. Um, oh wait, so okay, these last two lines are happening. Okay, you see my cursor? Yeah, these two lines here are happening simultaneously. I didn't connect that. Actually, oh wait, so this is all just, there's only 2 time periods in question here. 1986 in winter and 1987 in summer. Actually, all these last 3 lines are dealing with 1987 summer. Well, I guess from winter to summer. Okay, so maybe let's our goal is to find number of tourists in winter of 1986. So maybe let's try naming some variables for 1986 here and see how far we can get. I'm not sure exactly how, like where I'm going with this question, but I'm just kind of exploring right now. Okay, yeah, Bob. I think that's what I was like gradually going to get to. So let's say that I'm gonna use, I guess, N and T, number of natives, and I'll say winter of 1986. I'm gonna do everything in terms of winter 1986 here. And T is number of tourists. So from the first kind of piece of information we have there, the ratio of natives to tourists. So natives, the 2 I'm going to take as division is, so N over T is equal to 7 over 1. Yes. And then if we want to look at, okay, so this is from 1986. And then for 1987, so isn't it, if we decrease, wouldn't we want to do? So the natives decreased by 100. So wouldn't we want to construct a similar thing here? But since N is 1986 and 1987, it should be N minus 100, shouldn't it? And then, so yeah, Thunder, I think I agree with you. Okay, yeah. And then for the number of tourists, they increased by 220, so then we would do T plus 220. In the same ratio thing from the second line, 155 to 69. And then now we have 2 equations and 2 unknowns. So we can just solve this. And we want to find the number of tourists. We want to eventually solve for T here. So I guess, Thunder, how comfortable do you feel solving system equations what like this? Because basically we use these 2 equations at the same time to figure out what N and T are. I can like go through, but I want to make sure that I don't like zoom ahead without you like understanding. You understand so far? Okay. So do you want to see me like go through and actually like get the final answer here? I don't mind. I just don't want to do. Okay, yeah, sure. Okay, so I'm gonna. This one's a simpler one, so I'm gonna start with this one. I'm just gonna the number. So if we want the number of tourists, I'm gonna try and I want to get rid of the n in this equation because it's a more complicated one, so we can just end up with t, the number of tourists. So in this one over here, I'm gonna solve it for n in terms of t. So I'm gonna multiply each side of. Well, actually, let me just rewrite it. 7 over 1 is just 7, so I'm going to drop the over 1. Now let's multiply both sides by t. These 2 cancel. So we get n equals 7t. Now coming over here, if we know n is equal to 7t, we can plug in 7t for this n right here, and then we only have t's. So I think that's our best bet. 7t minus 100 over t plus 220 to 155 over 69. Okay. So I don't like the denominators. So now we just have one variable, so we can solve directly for t. I don't like having the denominators here, so let's multiply through by each of them. Let's start by just multiplying each side by 69. Oh, that's not 69, that's 66, isn't it? I just wrote another 6. I can't. Okay. So 69's there will cancel. Get 69, 7t minus 100 over t plus 220 is equal to 155. Now let's do the same thing, but with t plus 220. We'll multiply each side by that. Oh wait, is my face cam blocking this? Oh good, it's not. Not yet, at least. Okay, I'm going to switch over to the left-hand side after this line, just to make sure I don't cut off my own work. That will cancel with that. Let me come over here. Draw some nice math spaghetti arrows. So we get that numerator. 69, oops. (69 times 7t minus 100 is equal to 155 t plus 220. Okay. Now, unfortunately, we have some annoying math to do here. 69 times 7 is 69. Well, 69 times 100 isn't too bad. 69 times 7. I'm too lazy to go to Wolfram. Let's just do that by hand. Dude, it's been so long since I've actually done multiplication like this. I'm going to be honest. 3. Dude, why can't I write numbers? I said 3 and I wrote 6. 3, 6, 42 plus 6 is 48. 43, I hope. If I did math by hand wrong, then I don't know, man. What is with my brain? Okay, so 43 t minus 6900 equals 155 t 220 times. Okay, now I actually I'm not doing that by hand too. Uh, 155 times 220. I don't know why I can't write numbers today. 34,100. Okay. 34,100, I guess. Same thing. Okay. Now let's get the t's on one side and the not t's on the other side. 43 minus 155. Ooh. Ooh. That's going to be 300 something. It's going to end in 8. It's a number in the middle. 2? I think that, yeah, 328. Oh, yeah, we probably will get a decimal. Or we might, I'm not sure actually. It depends on how they made the numbers for the problem. Okay, 34,100 plus 6,900. The answer is something annoying. 40,000 something. That's gonna equal 1,000. Is it 4,100? We actually make it a decimal here. Let me verify this. I'm doing too much. Yeah, sure, Bob. Okay. 34,100 plus 6,900. Yeah, that is 41,000. I did that right. Now let's divide by 328. 125. So that, we don't get a decimal there. It is possible to get when you're supposed to round it down. That happens a lot in stats, but thankfully here they lined it up nicely for us. So 125? Okay. And that's just our answer, because if we solve for, it could happen we solve it for n instead, and then we have to go back and get t, which isn't that hard, but... Oh, really? Okay. So for the 1987 initial setup here, basically, it's the same exercise as what we did here for 1986, but it looks more complicated because it's just a more complicated situation. So the 155/69, I hope that was the right side. That's just from the ratio that we're given in the problem. And then with the way that we've defined our variables, I said that n is a number of natives in 1986. And so in 1987, we don't know exactly what it is, but it's whatever we had in 1986 minus 100. You could do it backwards too, where you define the variables for 1987, and then you have to do things the opposite, but I think it's a little bit trickier. And the same with t, that's defined to be the number of tourists in 1986, but when we fast forward to 1987, they've increased by 220. So it's the exact same thing as what's over here in 1986, but you have to adjust your n and your t for the population changes, and the ratio has also changed. So that's why the right-hand side changed. Yes, ratios are fractions, exactly. It took me a while to realize that too. You learned complex numbers before this? Yeah, a ratio is the same thing as a fraction. Okay. Glad to hear that. Let's see this person who's been asking about series. We've been going back and forth with them for probably a week now. Yeah, 7 days ago. You have a longer beard, Bob? Nice. I had never tried to grow my beard significantly longer than this, but it already starts to like curl out and do crazy things, so I haven't felt brave enough to try. The hair that's actually like on my head too, it also curls out and does crazy things, which is also like part of what I'm thinking. Curly beard is cool too, but it goes like out. It's almost like an afro, but with a beard. I don't think it looks very good. At least on me, I don't know, maybe someone else can pull it off. There's first asking about part E, but that's asking about part D. Let's look at the part D part first. Oh, maybe it's connected though. Okay, let's look back at part E then. Let's look what the question was asking. This is a very long, like multi-part question. My dial-up is going to take 10 years to load this. Okay. Let's actually open this in a new tab. Math was invented in 500 BC. Okay. Actually, I don't really get that. I'm going to be honest. What is our face supposed to be? I don't know. Yeah, what's up, Thunder? Too long? I mean, I get lost in math questions all the time, and I spend like an hour and a half on the same one. So depends on the actual question, I guess, but I'm happy to hear it, and I can tell you. Hey, Pin Center. I only just got to this one. We were doing other problems, but before this. Non-constructive proofs in general. Hate this one specifically. It is a very like, yeah, it just proves the existence. You're right. I guess that's why it's so weird to me. Um, okay, so what's up with this person? We've been going back and forth for like a week now, but um, I really like the way that they're like working through this problem, trying to understand each part. So, um, for part E, is it sufficient to say, given the sum series A, what does part E ask? More constructional context. Isn't that not always possible though? All right, so uh, Penson, like the thing we're talking about in particular was the problem that No Pro Bob posted and then gave that YouTube video explaining it. Oh, that is a joke. Okay. Sorry, I'm slow. Uh, the known close formula for two. Two is this. Oh, wouldn't you just you take? I thought we did that the last time, where you just take the a sub 0 multiplied by, wait, yeah, by d squared over d minus 1. Okay. Hey, mathematician, can you help me solve this differential equation? Okay. Solution exists and it's unique. uh, well, if you're a physicist, you just say it's approximately equal to some like polynomial or something, right? Applied math. Dude, okay, I'm playing music from uh a video game called Omori, and I really like the music in it. There's one specific song that I want to find it though. Let me just take a second. It's kind of a banger. Um, I don't remember what it's called though, also, which is a bit of an issue. And there's like 90 songs in total, so it's was it this one? No, I don't think it was that one. Was it? Oh, maybe it was that one. No, this one's also good though. I'll let it play. Actually, maybe it's all the way up here. This is this song is from one of the underwater levels in the game, and like I feel like in any game, the music when you're underwater is always the best. It might be that song, but I don't think it was. Okay, never mind. I'm just gonna work on the math. uh, Thanks for looking, Jeff. Let me expand this out a bit. There we go. Oh yeah, we'll hopefully be moving over to a new save system at some point. That'll be synced with other math streamers too, which will be fun. Just click the most. The things will be valuable someday. They'll be the next cryptocurrency. And you're getting in on the ground floor. Okay, I think that's all that needs to be said here. So we can actually, we don't need to spend a bunch of time on this one. I didn't even look through Reddit once today, which is, I mean, I'd rather have questions from chat, so that's always nice. Ooh. Now, I don't know what this means. Like, are they working on the question, or are they just like saying they're about to take a multivariable calc class? Let's see if I can remember Green's theorem. I do enjoy it, but I don't, I almost never use it, so I don't really remember it. Surface integrals, right? No. Line integrals. Yep. It's kind of weird. We don't have a function on the inside here. We only have a region. Oh, and that answers that question right there. How do you deal with a little... Okay, I guess we basically do this. Use green sand to find the area enclosed by r of t equals 1/2 sine 2t comma sine t. So they don't give us the bounds. Are there obvious bounds that we're supposed to figure out intuitively? Like, ugh. These will be equal at t equals 0. Well, it's gonna be like an ellipse or something weird, isn't it? Does Desmos do this? I feel like maybe they do parameters. Actually, it has to be sine and cosine to be, well, I guess they're just an offset of each other. I don't know what it's gonna look like. So like, is this a thing that Desmos won't yell at me for doing? It most certainly will. What if I did that one? This might need to be in the 3D one, actually. Hmm. Hardlocked, hey. Good to see you. So my separate in terms of C. Oh, that's probably it. Thank you, Pincenter. I'm not very good with Desmos. And then how does one slide? Uh, I oh really? Hmm. Yeah, freaking Desmos, man. Now this probably makes zero sense. I'm just gonna try this though. A equals one in a new line. Okay. Oh, there we go. Uh, it's not gonna do it at the same time though. Whoa. It's drawing it. This is like it's making a level curve, right? Oh, it's making a flower. Maybe. Wait, is this easily expressed in whatchamacallit? Polar? Well, there's no need to insult the flower, Pen Center. It's kind of rude. uh but how would I define this in polar when it's already like in a vector like this? I'm confused how I'm supposed to graph this, honestly. I know this makes zero sense. I just want to see if it can somehow work though. Like if Desmos will somehow eventually make sense of this. Hmm. Hmm. Oh, yeah. What does that look like? Oh. Nope, little t. Hey, stop. Thank you. It's doing the same thing, I guess. Can Wolfram Alpha like just understand what I'm trying to say here? Wolfram Alpha gets me, man. If I give it that, what is it gonna do with that? Oh, that's not what it was drawing in Desmos. And that still doesn't help us figure out exactly what the bounds are, does it? Actually, well, no, I guess you do it to the entire shape. I don't think Desmos was drawing that. Oh, maybe it is. Oh yeah, it definitely is. Okay. You could do 0 to pi and multiply by 2 as well, yeah. Take advantage of the symmetry. I doubt it makes a difference. Well, I don't think it makes a significant difference in like how hard it is to integrate either way. So if I just... Here's your real question again. So I assume I can just blindly copy what Paul's online notes did, but take these as, this is my x, this is my y, and then make my bounds either 0 to 2 pi or 0 to pi and multiply by 2. Let's see how that works out, I guess. That's cool. Okay. So, from Green's theorem, we have A is equal to 1/2. Is that line integral in the circle there? C x dy minus y dx. And we know x is equal to 1/2 sine t, 2t. So we need to find dx and dy here as well. Y is sine t. Dx is equal to cosine 2t dt, and dy is equal to cosine t dt. And to get rid of the 1/2, we could do the multiply by 2 and do 0 to pi thing, I guess. Uh, 0 to pi. Actually, no, we should verify that 0 to pi is actually half the shape. It might not be. It's like... Sometimes the drawing of it can be weird, can't it? Like, it doesn't always draw it how you expect it. I might actually just do 0 to 2 pi to be certain that I'm getting the entire area. Just look at the y value. Oh, I guess you're right. It would have to start from 0, go up, peak, and come all the way back down from 0 to pi. I could buy that. So we can even like start at basically 0 here. Actually, I mean, it's probably easier to see with this one. Start with a equals 0 and just bring it up to like 3 point... Okay, 3.1. Okay, that's enough to convince me that symmetry thing does work. I was saying that because sometimes it might draw like the diagonal first if you went 0 to pi for some curves like this. So it's always good to check that. And that's a nice trick to make sure that you're thinking about it correctly, Bob. Okay, so 0 to pi, 1/2, let's multiply by 2 so we don't have to worry about it. X dy, x is 1/2 sine 2t. Dy is cosine t dt. Is that going to be annoying? Wait, you're going to have to half angle? That's annoying. Is this some kind of identity though? Like, could you say this is... No, this is an identity here. No, the 1/2 messes it up. Oh, that's unlucky. That's nearly an addition identity for like sine of 3t or cosine of 3t. But the 1/2 in front means it's not. Oh, I hate that. I guess we're half angling, unfortunately. Let me get my identities up. Okay. I'm not being blocked by the camera, right? Okay, good, I'm not. They still come over here, though. 0 to pi. Now, sine of 2t is equal to 2 sine t cosine t. 2 times 1/2 is 1, so we can get rid of that. So this one actually isn't that bad. We just end up with sine t cosine squared t minus, now cosine 2t, we have a few options here. We have options in life. Ooh. We have a sine t already there. We can make it cosine squared minus sine squared. Might be good. We can make it cosine squared, or 2 cosine squared minus 1. Actually, that's probably better. Or we can make it 1 minus 2 sine squared, which I think is worse. I want to take 2 cosine squared minus 1. Because I think it'll give us easier integration. Not blocking my cam. Okay, good. This one we can do with a u sub. U equals cosine t. Actually, I'm going to integrate it, I guess, all at once. Let me do one more step. Two sine t cosine squared t minus plus sine t dt. And so none of these are going to be that hard to integrate, which is why I chose this particular identity. That's just the formula that I was copying from Paul's online notes. So Green's theorem has a few versions in this case, I guess. And I'm just blindly copying the particular one that was used in this example here. Ah. Choose a form so it fits you. Yeah, one of the other forms might have been easier. I'm already committed to this one, though. Let's make some math spaghetti. Okay, so actually this is annoying to that I'm going to do the u sub here. For this one, I'm going to do u equals cosine t, which means du is minus sine t dt. This one, the same exact, actually wait, these are the same thing. We can combine like terms on those. So let's actually do that before we u sub. They're both sine t cosine squared t. So let's do 1 minus 2 is negative 1. Plus sine t. Okay, now we'll do our u sub. Du is minus sine t dt. Okay, so this comes out to be 0 to pi. This is going to turn into u squared. The negative will cancel with a negative. U squared integrates to 1/3 u cubed, so we get 1/3 cosine cubed t. Sine t just integrates to minus cosine t. We are valuing from 0 to pi. Cosine of pi is -1. -1 cubed is -1. Minus -1 is +1. Minus cosine of 0 is 1. Is this 0? No, no, no. They don't cancel. We get 2 minus 2/3 is 1 1/3 is 4/3. Am I right or am I right? No, 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 no. Oh yeah, Taos, that's what I was trying to do when I first saw the integral. It's correct, so thank you for confirming that. Okay. So has someone... Okay, I don't know... I don't get why people post things that aren't helping the person. How should I explain this? So they got sine squared 2t over... Where did that come from? Take a pic and upload? I have done that before, actually. I don't know if that... Yeah, Penn Center. Um... Where did this come from? I'm going to take a screenshot of Paul. A little like a formula I used. I'm going to ask them where they got... I should just copy paste what they wrote, right? That'd be so much easier. Where's my screenshot? Okay, so let's see if they get back to me. Don't you just use Pythagorean on this one? No, that's not Pythagorean. You could say 1 is equal to sine squared plus cosine squared and see where that leads you? Is there a different way to do it, though? That's probably a good step too, Jeff. To work with the tangent. Let's see if we can figure this one out. Uh... Where am I? Hey, Anders. How's it going? Oh, I don't want to lose my Green's theorem work, though. Let me take a screenshot of this. I'm going to open up my own stream for a second. I just want to have this work easily accessible. No, no, no. Give me 1 minute. Okay. I got a screenshot of my work. in case I need it. Let me erase what's on the board now. No, 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 no. Ugh, dude. Is it the eraser? It might be the eraser. It does look like it's a little saturated. Okay. So guys, you don't remember the division algorithm works for angles and degrees, minutes, and seconds? Oh god. Thanks, Anders. Yeah, I'm playing it's a soundtrack to the game Omori, which I really like. Thank you, Hardlocked. Yeah, that's how it's spelled. It's a really good game. So for this identity, I want to work with the left side. So tangent squared, there is identities for tangent squared too, I think, which we can take a look at. We're doing things with x's or thetas? X's, okay. I'll write down the entire identity for the first line. Morph into Babylonian. 1 plus sine squared cosine squared. Oh, I know that they use base 60. I took a history of math class. I didn't think that I'd like it, but it was actually one of the more interesting classes that I ever took. Didn't like the Egyptians use like base 8 or something weird, right? I might be getting it mixed up. I feel like there's another like ancient civilization that used a non-10 base. Um, so I kind of want to say that this one is sine squared plus cosine squared and see where that leads me. We could also try, I think Jeff is the one who said it, that tangent squared is sine squared over cosine squared and get a common denominator. Uh, I kind of want to see tangent is sine over cosine. Actually, this is all, yeah, because everything is squared, so I'm sure we, I just want to see quickly if there is one, like what the tangent, oh no, the tangent squared one looks ugly. I don't want that one. Oh wait, but that one might be helpful though. Tangent squared plus 1 is secant squared. I was thinking a different tangent one. Uh, we can try that one, Talos. Just see where it leads us. It might be a good, so we can say that that tangent squared and that one is the same thing as secant squared. Dude, every time I write secant x, I always make sure that I don't write sex. Like every time I think that I'm about to do, I'm like, wait, did I do it right? Um, so I mean, now do we get a common denominator? Or like, and because with splitting the one, what do you mean with that? Like splitting the one into sine squared plus cosine squared? I'm gonna keep like going down this road for now, but I'm sure there's many different ways to go about this. Okay. So, really? Where does that? That can't be right. The identity is false. Oh, did I do the tangent secant one bad? Oh wait. Oh no, it's just the identity. Like this isn't a real one in the first place. That'd be a good thing to check. Thank you, Zone Ranger. I was like I did something like that. I'm like, uh, it's always good not to take those for granted, I guess. Not the first time. The playlist is madness. It's a game soundtrack, so there's some weird ones in there. Oh, okay. That's only true at certain values. Okay. Thank you for checking that, Zone Ranger. But yeah, the mood of the music is kind of all over the place. Also, change the division for the cosine squared x to multiplication, and it's true. Okay. Wait, that is a multiplication dot and not a division sign, right? Yeah, that is just a dot.